Morning folks, today we'll be having a look at factor theorem and algebraic division. The work that I'm setting today is intended to cover Wednesday and Friday, so work through at your own pace. Don't worry if you don't get everything done today, but whatever isn't done on Friday will need to be completed for homework. So factor theorem is something that you may have already been introduced to. I think certainly it was on GCSE further maths. It may be something you saw this year already as well, but let's state it. So factor theorem is essentially saying if you have a polynomial, fx, and if you have a number a that you can substitute in there and you can get an answer of 0, then that means that x minus a is a factor of that polynomial. And I put in red here that the reverse also applies, that if x minus a is a factor, then if you sub a in, you'll get 0. So obviously, write this down. There's a lot of uses for this in terms of solving things quickly, but we're going to hone in particularly on cubics and quartics. So let's look at an example here. We've got a polynomial, x cubed plus 6x squared plus 5x minus 12, and it says that we need to find the values of f of 1, minus 3 and minus 4. So let's do that. So I'm going to do f of 1, that would be 1 cubed plus 6 lots of 1 squared plus 5 lots of 1 minus 12. This would be 1 plus 6 plus 5 minus 12, and that equals 0. Notice what I've done there is about the minimum that you want to get away with when it's saying show that this equals 0. It's obviously not enough to just type it in and say I got 0. You have to show the calculation. Let's do the other two. I think we're going to get 0 out for them as well, but we'll find out. I reckon you could probably get away with saying like this is minus 27, this is 6 times 9, remember everything squared is positive, 5 times minus 3, minus 12, so this would be minus 27 plus 54, minus 15 and minus 12, and that is 0 as well. And let's do the same with minus 4, this would be minus 64 plus 6 lots of 16, plus 5 lots of minus 4, minus 12, so that would be minus 64, add 96, minus 20, minus 12, and yeah, that gives 0 as well. So we've taken three values, we've substituted them into the polynomial, and we've got 0 out in every case. And because of factor theorem, this means that x take away this number is a factor. So this will tell us that x minus 1 is a factor. This will tell us that x minus minus 3 is a factor, but we normally say so x plus 3 is a factor. And similarly, this will give us x minus minus 4, so x plus 4. So these are all factors, so we can use that overall to factorize fx. We can say that our polynomial is x minus 1, x plus 3, x plus 4. Now, that is not the usual use of factor theorem, but hopefully it's an intro as to how we can actually deploy it. What's normally going to be the case is that we work out like one factor and that we use some algebraic division after that, and we'll come into that in a little bit. So, let's look at another example of a question here. We've got x plus 1 is a factor, and we want to use this to find the value of a. Okay, so this is using the reverse of factor theorem, which is if this is a factor, then f of a is equal to 0. So again, we'd think about this as being x take away minus 1, and that would mean that f of minus 1 should equal 0. So let's substitute that in. 4 times minus 1 to the power of 4, minus 3 times minus 1 squared, plus a should equal 0. So this will give us 4 minus 3 plus a is 0. Yep. And that will tell us that a is minus 1. So, again, another simple use case. If we know what a factor is, we can substitute the inverse of that value into the polynomial, and we can get facts about the other values within it. Okay, but usually it's not just a case that it's factor theorem on its own. Usually it's that we're going to use factor theorem to find one factor and then algebraic division to find the others. And I'm going to go over my favourite type of algebraic division today, which is the grid method, and I'd like you to try and use it. Because it's a nice quick and compact way of breaking up things like cubics and quartics. So, here's our exam style question. We've got fx is x cubed, 3x squared, minus 33x minus 35. We want to show this as a factor and hence fully factorise it, and we're going to sketch it as well. So we're kind of doing everything at once here. Let's, I guess, split this into 3 parts. That could be our A, our B and our C. So for our part A, we just need to show that this equals 0. Now the word show that means that we're going to need to say something about it. But let's sub it in first. So minus 1 cubed plus 3 lots of minus 1 squared, minus 33 lots of minus 1, minus 35, what's that? That's minus 1, plus 3, plus 33, minus 35, that'd be 36 minus 36, that's 0. And therefore we can say x plus 1 is a factor. Easy enough. Of f of x. Okay, hence fully factorised then. So let's go on to this algebraic division stuff. So what we're going to do is we're going to draw ourselves a grid, and we are going to be dividing by x plus 1. And the way this works is we start by writing in the top left corner here. You can basically imagine there are sort of lines here as well. We're going to divide, so it's x cubed is the highest power in our actual division. So we're going to write x cubed up here. Just move that plus across. Now, think about your grid method here. This is a multiplication grid, so what would you times by x that would give you x cubed? Well, you would times it by x squared, so we can fill in an x squared here. What would we get if we did this value here? That would be 1 times x squared, so we'd write an x squared here. And then we look back at the question and we think, okay, how many x squared do we actually have? Well, we actually have got 3 x squared. We've only got 1 of them so far, so we need to have another 2 x squared. So this like diagonal has to add up to our 3x squared. If that's 2x squared, then what are we going to write on the left here? Well, we're going to write in 2x, because x times 2x will give us that 2x squared, and we're going to write plus 2x over here, because, well, that would be 1 times 2x. And then what do? We look at our quadratic again. We think, well, we've got minus 33x here, but we've only got 2x so far. How do we make that into minus 33x? We take away 35x. So what does that mean this number on the left is going to have to be? Well, that's going to have to be minus 35, because that's x times minus 35. And this is going to have to be minus 35, because that's 1 times minus 35. We have one last look back at the question, and we think, well, we've got minus 35 here, we've got minus 35 here, so we're done, there's no remainder. And you can read off the division on the left-hand side. So what can we say here? We can say that our f of x, woo, careful there, Microsoft Word. We can say that our f of x is equal to x plus 1, because we already showed in part A that's a factor, and then x squared plus 2x minus 35 as our rest of our polynomial. You can then factorize this using, standard quadratic factorizing techniques. We need to multiply to 35 and add to 2, and those numbers are going to be 7 and minus 5. So that gives us overall our factorization. So it's a really neat, compact method if you're on top of it. Let's look at another one. Oh wait, sorry, there's a part C. Part C, we want to sketch the graph. Now this is a cubic graph, so we should know that the general shape of it is something like that. Positive cubic. If it was negative, it would start high and end low. And we've got our three crossing points here with our factorization. We know it crosses at -1. That comes from this factor here. We know it crosses at -7. That comes from this factor here. And we also know it crosses at 5. That comes from this one here. We know the shape, so let's put those two things together and let's draw our cubic. It's going to go up and down and up again. We could also say that it crosses the y-axis at -35 because that's like the intercept at the end, but normally we're just interested in those points. So yeah, that's the basic idea of factor theorem and algebraic division all at once. Let's use it again. So we've got here f of x is 2x cubed, etc. We want to show something is a factor, we want to hence factorize, and we want to sketch. Now feel free to have a go at this one yourself, but I'm going to go straight into it. So for part A, we'd want to find the value of f of 2. So we'd have 2 times 2 cubed plus 3 lots of 2 squared minus 18 lots of 2 plus 8. So that will be 16 plus 12 minus 36 plus 8. That equals 0. Therefore, using the factor theorem, x minus 2 is a factor of fx. Cool. Part B, hence we want to factorize this expression. So we'll put our grid down. We'll write along the top x minus 2. We'll make sure we know this is a multiplication grid. And then in the top left, we're going to put the biggest power, the 2x cubed. What does that mean needs to be on the left? That needs to be 2x squared. Again, multiplying the x by the 2x squared to get that. This will be minus 4x squared. But we don't want minus 4x squared. We want 3x squared. How do we get there? We add 7x squared. So those two have to add up to our 3x squared. If that's 3x squared, that means this 7x squared rather, that means this is 7x. And it means this is minus 14x. But we don't want minus 14x, we want minus 18x. So we want another minus 4x. So those two have to add up to minus 18x. So this is minus 4. So this is plus 8. And yeah, that's exactly what we want, so we know we've not made any mistakes there. So our factorization would be x minus 2, 2x squared plus 7x minus 4. And that would factorize to 2x minus 1, x plus 4. Again, you could go through a slightly more in-depth process to do that if you wanted, but that one just leapt out at me. Hence, sketch it. So again, we'd think, is this a positive or a negative cubic? It's positive because it's 2x cubed, so it's going to go like that. We know the three crossing points are going to be 2, half, and minus 4. So let's mark them. Obviously note with a sketch, it does not matter how accurate your drawing is in terms of scale, as long as it's in the right quadrants. Then connect our shapes or points together, and we know it goes through the axis at 8 because of the intercept. Final use of our factor theorem is that we can create some simultaneous equations using it. Here's an example. We've got two factors of our cubic, and we want to use them to find what P and Q are. So, this one tells us that f of 1 should be 0, and this one tells us that f of minus 1 should be 0. So let's work them both out. First one will tell us that P of minus 1 cubed, so just minus 1, plus q of minus 1 squared, minus 3 lots of minus 1 minus 7 equals 0. So if we simplify that, we'll get minus p plus q plus 3 minus 7 is 0, or q minus p minus 4. It's about as far as we can simplify it. The other one will tell us that p plus q minus 3 minus 7 equals 0. So that will tell us p plus q minus 10 equals 0. And at that stage, you have two simultaneous equations that we can try and solve. Now if I write them on top of each other, so the other one is q plus p minus 10 equals 0, you can solve these by adding together, can't you? So if we add them, we'll get 2q minus 14 equals 0, and we'll get q equals 7. And then we could substitute that back into either of the expressions. Let's use the bottom one. We get 7 plus p minus 10 equals 0, so p equals 3. Be a good idea to check these things work. So 7 minus 3 minus 4 is 0, yep, and 7 plus 3 minus 10 equals 0, yeah. So there's our value of p and q. Finally, going to finish off with a couple of exam questions showing sort of things they could ask in these sort of scenarios. We've got again a polynomial. We want to show this as a factor of fx. I think for these you should have a go first and then have a look at my answers, but I'm going to crack on, so pause the video, have a go, and then let's look at what we've got. If this is a factor, that means that f of a half equals 0, because that's what would make that bracket 0. So f of a half would be 2 lots of a half cubed plus 3 lots of a half squared minus 18 lots of a half plus 8. This will give us a quarter plus 3/4 minus 9 plus 8. So that's 1 minus 9 plus 8. That equals 0. Tick. Done. Therefore, 2x minus 1 is a factor. So is x minus a half, I guess, but we could just scale it up. It says, hence, we need to write it in this form, so that's now the dividing step. So again, let's put down our grid. 2x minus 1. The number in the top left has to be 2x cubed, which means this is x squared, which means this is minus x squared. But we want 3x squared, so we need to add 4x squared to that. So this is 2x, so this is minus 2x, but we don't want 2x, we want minus 18x. So that means this is going to have to be minus 16x, so this is minus 8, so this is plus 8, and plus 8 is exactly what we expect to get at the end. So our factorization would be 2x minus 1, x squared plus 2x minus 8. Done. And then we've got a hence to this where we've got to do things with it. So the first thing we want us to do is that we want to simplify an algebraic fraction. Now this thing on the bottom of our algebraic fraction is exactly what we've just factorized. And I will point out that I think we can factorise this a bit further, can't we? So this isn't actually part of part 2, but we're going to use it, so let's do it. We can factorise that into plus 4 and minus 2. So if we want to simplify this algebraic fraction, as we said with algebraic fractions, factorise everything first. This will be 4x, x plus 4 on the top, and it will be 2x minus 1, x plus 4, x minus 2 on the base, and all we can do to sort of simplify that is cancel out the x plus 4's, so we'll end up with 4x over 2x minus 1, x minus 2. Okay, and let's look at our final question. We've got a polynomial again, k is a constant. Given this is a factor, show that k equals 10. So we know by now we need to substitute in minus 2 and set it equal to 0 because it is a factor. So minus 2 cubed, minus 4 lots of minus 2 squared, minus 7 lots of minus 2 plus k equals 0, and then obviously work this out. So that would be minus 16 plus 14 plus k is 0, so that's minus 24, so that's minus 10 plus k equals 0, and that tells us, yeah, that k equals 10. And then hence express as a product of 3 linear factors, so again that's our classic factorise this now, which is, what do we want to do? Let's draw our grid. We are dividing by x plus 2, and let's try and get the polynomial in play. So it's x cubed plus 4x squared. So x cubed in the top left, that means that's x squared, that's 2x squared. But we want minus 4x squared, so let's take away 6x squared, minus 6x, minus 12x. But we want minus 7x, so plus 5x, which means this is plus 5, which means this is 10, and 10 is exactly what we wanted it to be. So our polynomial is x plus 2, x squared minus 6x plus 5, and that would factorise to x plus 2, x minus 5, x minus 1. And then part B, final part here, we want to sketch this. We know it's a positive cubic, we know it goes through at 5 and 1 and minus 2. Started drawing a negative cubic there. So go through your 3 points, indicate the values where the curve crosses the x-axis. The y-axis is the plus 10 intercept at the end. Okay, cheers. There's going to be some questions to do. Best of luck this week.